AI is incredible. Transformers changed everything in just a few years. We can automate almost anything now. But nobody talks about what happens when you push past the context window. Everything falls apart. There are solutions, workarounds. None of them actually fix the problem. The two things that keep breaking: memory and hallucination. Working with LLMs feels like managing a kid with ADHD sometimes. They forget what they were doing halfway through. No memory. And without memory, they start making stuff up. Compaction helps a little, not much. So how do you actually fix this? Memory. Okay, but how? Markdown, JSON, indexing, RAG, graph. Confused? Good. A small ML project taught me more about this than any tutorial ever did. Let me back up. Last semester of my master's in CS machine learning course, I had an ML project due alongside my capstone, EcoSmart Loop, which was built to tackle a $640 billion waste management problem. I wanted to build something that solved a problem I was actually dealing with. Job search, layoffs hitting senior talent, markets brutal for juniors, new AI roles everywhere, tons of job platforms popping up. The problem? None of them are tailored to you. LinkedIn's job AI is limited. ChatGPT is worse. All these new platforms, same story. Not because they can't do better, it just makes more sense for them to build a general experience for everyone. AI features are expensive. So here's the truth. No company is going to build something tailored specifically to you. That's not their fault. They have competition, demands, limited resources. Don't blame them. Blame yourself. We have all these powerful tools now. Why not build something for your own needs? That thought stuck with me. I decided to build a project that could give real tailored suggestions. User profile, resume docs, job descriptions, company info, actual match scores, everything that matters. I built SOKK, Smart Outreach and Knowledge Keeper, career assistant powered by ML. The problem I was solving: when you ask ChatGPT for resume advice, about 24% of its suggestions are made up. Skills the job doesn't actually need. Experience you don't have. Requirements that aren't in the posting. You can't tell what's real from what's hallucinated. My approach was simple. Verify everything before showing it to users. Different from how everyone else does it. I called it a dual gate architecture. Most AI assistants generate first, maybe check later. Usually never. SOKK flips that. Every suggestion has to pass 2 verification gates before you see it. 5 input sources feed into a weighted RAG system. Job posting at 35% weight, your resume at 25, profile data at 20, other resumes at 10, company research at 10. AI generates a suggestion from all that. But before you see anything, it goes through 2 gates. Neural gate uses LLM as judge to check if it's faithful to the sources. If SOKK suggests add your GraphQL experience, it checks. Does the job actually need GraphQL? Do you actually have GraphQL somewhere in your documents? Symbolic gate enforces quality rules. Does it mention the job title? Cite a real requirement? Under character limits? Professional tone. Call to action. Score 0.9 or higher on both gates. Suggestion is approved. Between 0.7 and 0.9 shows with a warning. Below 0.7, blocked. Hallucination caught. Hallucination rate dropped from 24% to under 3. Why does the cost trade-off work? This approach costs more. Gemini for AI, Voyage for RAG, Exa for research. Multiple APIs. Companies building done-for-you solutions have to optimize hard or cut features to stay profitable. But for you, spending a few bucks for actually accurate results makes sense. DIY workflows with AI are worth it. Open source LLMs make it cheaper now. You have options. After SOKK, something clicked. Wait, I can RAG my entire codebase. If you use Cursor, Copilot, or Warp, same idea. They call it codebase indexing. Makes the AI smarter instead of searching everything fresh every time you ask a question. What you get? Finding code by meaning, not just keywords, only relevant code in context. AI actually understands your patterns, how you do things. This isn't about finding files faster. It's about giving AI real understanding of your project. not treating every question like it has amnesia. I built my own system, UOCE, Universal Oak Context Engine. 2 embedding types, voyage context for markdown and docs, voyage code for actual code. Then re-ranks with RRF, reciprocal rank fusion. Made it get aware too, knows what changed recently, what's been stable, what's new. The architecture. Query comes in. Intent classifier using Gemini Flash categorizes it in under 10 milliseconds. Then 3 queries run parallel. OakSearch does hybrid BM 25 plus vector with 0.3 to 0.7 weighting. Serena handles session memory for the current project. Core is long-term graph memory across all projects using Neo4j. Results merge with RRF fusion. Pointer system sends full results to disk. Only about 300 tokens go to the LLM. 67 to 95% token reduction. Context quality stays the same. But honestly, this is stuff everyone does now, makes AI smarter across the code base. Still doesn't fix the memory degradation problem though. I fixed the memory problem with dual memory. Serena memory handles short-term stuff, session context, directory structure. I write handoff notes before sessions or when switching tasks, then load them back later. Think of it as where was I memory, hours to weeks. Graph memory is the long-term layer, connects everything across all projects. Built my own Neo4j graph with Gemini Flash, intent search, saves my preferences. Best practices I've picked up, architectural decisions, second brain that gets smarter over time. Routing is simple. Session context stays in Serena, temporary, project specific. Big decisions and patterns get promoted to core. Permanent, cross-project. Debugging notes get deleted. Took me a while to learn this. Not everything deserves to be remembered. Smart forgetting matters as much as smart remembering. Still had to manually trigger saves and loads though, annoying. So I set up Claude hooks for auto triggers. Hooks use Gemini Flash to figure out intent. Instead of saving everything, it decides what's actually worth remembering versus routine debugging noise. What do the triggers check? Is this a decision or just an experiment? Reusable pattern or one-off? Checkpoint moment or mid-task noise? No more manual overhead. Runs in the background, captures what matters. Tools that worked for me. Serena MCP for memory and session context. Neo4j or core memory for graph storage. Core memory sets up everything. It's open source. Morpheme for bulk edits across files. Warp-grep for semantic search. Workflow's been solid. Looking back, few things would have saved time. Context engineering matters more than prompt engineering. I mentioned this in the EcoSmartLoop case study too. Once I gave AI specific context instead of generic prompts, quality changed completely. Spent too long writing perfect prompts when the problem was always context. Build incrementally. I over-engineered the memory system before proving basic RAG even worked. Should have validated each layer before adding complexity. Test memory early. Handoff protocol was an afterthought. Should have been day one. Lost so much context between sessions in the early weeks. Checkpoint more. I save every 30 minutes now, not just session end. Lost an hour of context to a crash once. Learned that the hard way. The numbers. Hallucination rate. 24% before, under 3% after. Dual gate verification. Retrieval accuracy up about 14% with 2-stage pipeline. Context degradation normally shows log linear decay. Memory system fixes that. Token usage. 67 to 95% reduction with the pointer system. Research backs this up. RagTruth ACL 2024 analyzed 18,000 responses. RAG helps but doesn't kill hallucinations without verification. Halogen ICLR 2025 benchmarked 150,000 generations across 14 models. Proactive interference study. Log linear decay in retrieval accuracy comes from interference, not just context length. Context discipline study. Over 1,000% latency spike at context boundaries. Practical limits hit around 80 to 85% of theoretical max. What I saw matches the research. RAG improves relevance but doesn't fix hallucination. Verification does. Context degradation is about interference, not just token counts. This isn't just for coding. Same patterns are showing up everywhere now. Perplexity, GPT, Grok, all adding memory across chats. Industry figured out stateless conversations hit a ceiling. Memory is expected now. What I built for SOKK and UOCE. Same patterns these companies are implementing at scale. I just built mine for my workflow. Job searching right now while building these workflows out. We'll share more after I land something.